Hi everyone. So now that we've practiced using or solving systems of equations, we're actually going to use real life examples to and use our systems of equations processes to solve them. So there's several different types of problems where we can use systems of equations, and I'm going to go through four different types. I'm going to call them the general type. We're also going to look at distance equals rate times time. These also are going to apply when you take physics. There's mixture problems, and then there's also break even problems, which involve an average rate of change. All right, but let's get to work. Since a system has two equations with two distinct variables, in most cases, remember there's some that just have one variable, then a word problem will have two variables. That means that you have to look for two unknowns. Now, I've told you over and over this year that you look at the question being asked for the unknowns. It's not always evident, but usually it's in the question. All right, and then you must write a let statement stating your variables before proceeding. Okay, normally systems are going to be written in standard form, so I always suggest that when we're solving systems, we're going to use elimination. It's not always true. You're going to see there's a couple distance equals rate times time where it's just much easier to substitute. But most of the time, I find that elimination is a great use because it's in standard form. All right, let's get to work. So just a general system. So a general system is a system in which one equation usually is going to relate to the value of something, whether it be the monetary value or anything like that. And one equation usually relates to the total number of items. Okay, so here's a really good example. The band is organizing a trip to a national competition for the 226-member marching band. A bus will hold 70 students and their instruments. A van will hold 8 students and their instruments. A bus costs $280 to rent. A van costs $70 to rent. The boosters have $980 to use for the transportation. Write a system of linear equations and solve to find how many buses and vans should be rented. Okay, so first we want to identify our variables. They come from the question. It says how many buses and vans should be rented. So I'm going to let B equal the number of buses. And I'm going to let V equal the number of vans. Okay, so now we said one of them relates to the total number. Okay, so that total number we have is 226 members, okay? But 70 can go in buses and 8 can go in vans. So I would say 70 students times the number of buses plus 8 students times the number of vans has to be equal to 226 total members. I've got to make sure everyone's got a seat. Okay, my second equation, though, is going to relate to the value of the buses and the vans, or the cost in this case. So a bus costs $280, so 280 B times the number of buses, plus 70 times the number of vans is going to equal the amount that I have, which is 980. All right, so let's figure out how many buses and vans we can rent. All right, so now again, these are in standard form, so I find that elimination's the best, and I notice that 70 and 280 can easily be the same number but opposite signs, so I'm going to multiply the top by a -4. So I'm multiplying the top equation by -4. Let me give myself some room here. And I'm going to rewrite the equation right below it neatly. So -4 times 70 is -280 B. Minus 32V equals, and then 226 times -4 is going to give me -904. Okay, now I'm going to add these two equations together. And sometimes it's just helpful to kind of put a little, like a line through that when I'm done with it, when I've changed it, so I don't get confused. All right, so the B's are going to cancel. 70 minus 32 is going to give me 38 vans equals, and 980 minus 904 is 76. So when I divide by 38, I get vans equals 2. All right, so that's telling me that 2 vans, but now I also need to find the number of buses, so I'm going to plug it in. I decided to plug it into the first equation just because I thought it was easier. That's 70b. So let me switch to black. So 70b plus 8 times 2, which is 16, equals 226. Subtract 16 on both sides, so 70b equals 210, and b equals 3. Now, it's a word problem. Answer the question being asked. I need 2 vans and 3 buses. And there we go. There we have it. All right. I want you to think that one through, look at what we did, and what I'm going to ask you to do is to press pause, and I want you to try it on this next example. Okay? So press pause and try it. All right. Now I wrote, it asked me how many of each type of golf bag are in the shipment. We had both full size and collapsible, so I let F equal the number of full size bags, and I let C equal the number of collapsible bags. Okay. My first equation related to the total number of bags, so F plus C equals 124. My second equation related to the value or the cost, so 3850 F plus 2250 C. Oops, that's not a C. 2250 C, and it probably could just put 0.5, equals 3430. All right, I decided to use elimination again. You may have chosen substitution, but with decimals, it really gets tricky, so be careful if you do that. All right, so I multiplied the top by negative 2250. I picked the smaller value to make opposite. And that gave me, when I rewrote it below it, it gave me negative 2250 F minus 2250 C equals, and that worked out to be negative 2790 when I multiplied 2250 times 124. All right, so I'm going to kind of just put a little scribble through that just so I don't get confused. I'm going to add the equations together, and I got 16F, these eliminated, equaled 640. Divide by 16, so F equaled 40, and that gave me 40 full size and 84, because 40 or 124 minus 40 gave me 84, so 84 collapsible. All right, so hopefully that one you did okay with. If you have any questions, please bring to class tomorrow. Now we're going to look at the second type. This is the other one we're going to look at today. So we're only looking at 2 of them today. This is my favorite. Okay, I love these. These are called mixture problems, all right? So what's a mixture? You mix things, right? We mix them in a bowl. We mix them in bags. When dealing with mixture problems, we are actually mixing something. Each item added is going to have 2 components. So one component or equation usually relates to the amount of each item, just like we just did. For example, there might be 2 pounds of raisins or 200 milliliters of a solution. That's the amount. Another component that's going to be related to the item would be the price or the percent. So I could have the price of the raisins or the percent of acid of the solution. All right, so then the 2 items being mixed will then be mixed together, or mixed together, or I've got together there twice, to make a whole quantity. And if we really think about that, we're going to have like mix 1 plus mix 2, and I could add more if there were 3 mixes, is going to equal our new mix, or whatever we're trying to get to. All right, so let's look at an example. So here we have a health food store sells a mixture of raisins and roasted nuts. Raisins will sell for 350 kilograms and nuts sell for 475. How many kilograms of each should be mixed in order to make 20 kilograms of the snack that will be worth $4? All right, so now the way I do mixture problems is I like to see a visual of it. So I make bowls. So I have my first bowl. That's going to be the raisins. And my second bowl is going to be the nuts. That's going to be what I mix together to get my new mix. Those bowls are going to help me come up with my equations. But first, I've got to write my variables. So we've got two different things. So we're going to let R equal the amount or the number of kilograms of raisins. I'm really specific when I set these variables so that I know exactly what I'm doing here. And N is going to be equal to the number of kilograms of nuts. So when I'm finished, I can look at those variables and they're very clearly going to tell me what to do. All right, so the first equation relates to the total number that we have or amount that we have. And I put that at the bottom. So I'm going to do that in red. So I want to make 20 kilograms. So my final mix is going to be a total of 20. Well, I'm mixing raisins and nuts to get to that 20. So R plus N equals 20. The other equation relates to the amount. So the cost in this case, so raisins sell for $3.50. I put that right here. Nuts sell for $4.75. I put that here. And we want the mix to be $4. Now, here's the additional step we have to take. We actually have to multiply those values to the raisins and the nuts. So I do 350 times R, these two, and I get 350R. 475 times N gives me 4.75 N. And then 4 times 20 gives me 80. So my second equation is what's in the bowls. So I'm going to write that out for myself. 3.5R plus 4.75 N equals 80. And R plus N equals 20. All right, so one technique I do want to show you right here is there's decimals, and if you ever have decimals in equations, you can do just like you did with the fractions. You can actually clear them if you want. You could multiply this by 100. You have 2 decimal places in that 475, so you could do that if you want. I chose not to because it was just small numbers, and I decided to multiply the bottom equation by a negative 3.5. So I multiplied the whole equation and I got negative 3.5R, minus 3.5N equals 20 times negative 3.5 gave me negative 70. Now, because Coach Fred always likes to be neat, I actually am going to rewrite this so it's right above it or right below it. So 3.5R plus 4.75N equals 80. So here's my revised system, and now I can solve. The raisins are going to get eliminated, and then negative 3.5 plus 4.75 gives me 1.25N equals 10. I divide by both sides by 1.25, and I got N to be 8. Okay? All right, now let's go back and think about this. If there were 8 kilograms of nuts, okay, so there's 8 kilograms of nuts, well, 12 plus 8 gives me 20, so there would be 12 kilograms of raisins. All right, guys, I know you might need to stand and stretch right now, so press pause, take a quick stand and stretch. One more to go. We're almost there. This one happens to be, I think, the hardest to sometimes see. All right, you're back, ready to go? All right, so mixing solutions. Now, you do mix solutions in chemistry next year, so you're going to see that this is a really common thing that happens. Now, the process is still the same. We see that we're mixing 2 solutions together to make a whole solution. So I'm going to make my bowls. I'm going to mix the solutions in bowls. 2 solutions being added to make a whole solution. All right. Now, we don't know what the solutions are, so I'm just going to let X equal the amount of solution 1. And I'm going to let Y equal the amount of solution 2. Now, I notice that they're in liters, so I know that my answers are going to be in liters. Okay? All right, now remember, one of them relates to the total number or the total amount, and I want to make 200 liters. So that means my 2 solutions, X plus Y, has to equal 200. Now, the percent is the amount, like the value as in the other one. So my first solution, I want it to be 80%, which is 0.8. And the second solution I'm mixing into this is 30% acid, so that's 0.3. My final solution, I want it to be 0.62% acid. So I multiply them and I get 0.8x plus 0.3y equals 0.62 times 200 gave me 124. And there's my two equations. 0.8x plus 0.3y equaled 124, and x plus y equaled 200. All right, you know what? This one I just looked, and I am going to multiply the top equation by 10 to clear those out. So I multiplied by 10 because there's one decimal I want to get rid of, and that gave me 8x plus 3y equals, now make sure you multiply the 10 to the 124 to get 1240. All right, now, looking at these equations, this one's kind of gone now. I need to multiply the top equation by a -3 so that I can eliminate. So I have one variable that's opposites. So -3x minus 3y equals -600. Add the equations together and we get 5x equals 640 and x equals 128. All right, so that's telling me that the amount of solution 1 is 128 liters. So of solution 1. And then since they equal 200, 200 minus 128 gives me 72. So 72 liters of solution 2. All right, guys, great job today. If you need to go back and watch this, I know it's been a long night, but please do. And we're going to be practicing mixture and general problems tomorrow in class. Have a great day.